speed run your substitution. How much time I have? How much time I have? Whatever. Okay. But I had to go get the basketball, so I just sneak this way. Huh? No, that one went flat. That one's like not that good. Yeah, that ball was the N1 ball. N1 ball kind of shitty. All right, so integration of x squared plus 1 to the 2x dx to the fourth power like this. So normally it's set up in this pattern. The pattern, oh, sorry. Quick time. Normally it's set up in this pattern. It's, you see that there is a 1 degree difference here between this one and this one. And see that 1 degree. So what you can do is this dx you can change to du, and then the x you can change in term of u. So u equal to x squared plus 1. Now, usually I will do something called differential. Is I'm going to do du, like you take in derivative, but just write down du, but without the dx part. So here it's going to be 2x dx. Always write this out because this is something to help you. And after the step, I will always solve for dx. So dx equal to du over 2x. In this case, then I will have everything in terms of u now. See, this is u to the 4. Now, I'm going to have 2x, but dx, I'm going to change to du over 2x. So this is going to cancel out. So that's going to be u4 du. And this is a u5 over 5 plus c. And then it's going to be x squared plus 1 to the fourth power over fifth plus c. Or fifth power, sorry. Now, if you think about it, if I take a derivative of this, right? 5 and 5 is going to cancel. It's going to be x squared plus 1 to the fourth power times derivative inside of 2x. Jared, does that make sense?
Yeah, except for the last. If you did the derivative normally, you would make x1 at 5, make it over 5.
So it'll be 5x squared plus 1 to the fourth over 5 times 2x. So does it go back to before, right?
Where'd you get the 5 on the 5 that you multiplied with?
It's a chain rule.
Yeah.
Like the x.
You take it down to 5.
Yeah. You bring down to 5, and 5 minus 1 is 4.
Does that make sense?
Yeah.
No. Okay, so you might get some like this. What does u have to be? You want to think about u has to equal to something that can help you solve the problem, because you want to think about the next step. You want to think about du. What does u has to be here?
X.
Good. Normally people do not see that fast because, but you are Jared. Du equal to 5 dx. And if you see that du over 5 equal to dx, now I can change that. 5 cosine of u. Oh, sorry, this is x. So that's going to be du over 5. 5 and 5 cancel out. That's going to be cosine of u, du. Integration cosine u du is what? What derivative is going to give me cosine? So sine u plus c. So it'll be sine of 5x plus c. Does that make sense? Okay. I'm going to ask you a couple.
So it'd be a 1/5? Wait, would it be?
Did I miss 1/5? Yeah, I did.
Yeah.
Okay, so how about...
Can you go back? Yeah, cosine du, sine.
This is the 1/5 here.
Yeah. So you bring out the
Way too efficient. Way too efficient.
If you, when you converted from dx to du, you went du over 5. So then you cancel out the 5s.
So remember, you replace this dx. Oh yeah, you cancel out
Oh,
the
I'm
5.
sorry.
Yeah, yeah.
I'm sorry.
Oh no, I cancel out the 5. You're right.
That's my bad. Yeah. I didn't see.
Confused. Not my fault. So that 1/5 and the 5, they cancel out.
I didn't see that, Tom. You can't see that.
Okay, so let's just say if I have x to the square plus 1 to the 5th power dx, do you see what u has to be? Yep, u usually inside the parenthesis. So what is the du?
X dx.
No, 2x dx. And then you always solve for this, kind of prevent that from happening. So u to the 5, there was an x, there was a du over 2x. See, there's a 1 degree difference, so they can cancel out. So it'll be 1/2 u to the 5th du. Is that okay?
Yeah, but why do you need the 1/2?
It doesn't cancel out.
You want to take out 1/2 outside because so you just focus on integral u to the 5th.
But why do you need to make du 2x dx? dx dx.
Because you are evaluating for dx. And you had to divide by 2x on both sides.
He defined it so he does u equals x squared. When you take the derivative, you get du over dx is equal to 2x, and then he multiplies.
Oh, that's it. Okay.
Yeah, that's how.
I just okay. Because for all the other like du's, it was whatever's on the outside. So I thought you knew. But taking the derivative of u to get the derivative of u makes.
Okay, so this one is gonna be x squared plus 1 to the 6th over 12 plus c. Is that okay? How do I take a derivative? How do I take an integral of this?
U 2x minus 1.
And you're probably gonna say, well, there was nothing outside, but if you think about inside's first degree, outside should be 0 degree, which is constant, which is fine. Because u equal to 2x minus 1, what is du?
2.
2 what? Dx. You had to make sure you have a dx there, because you can change a du over 2 equal to dx, so that's integration square root u du over 2. So it'll be 1/2 u to the 1/2 du, and that's u to the 3/2 2 over 3 times 1/2 plus c, so 1/3 u, which is 2x minus 1 to the 3 over 2 plus c. Is that okay? Too fast for you, or is it okay? I'm like trying to push your limit, Jared. See how fast I can go. I'm like speed run the cup one.
It's fast, but I think it's fine.
Okay. Now this one I'm gonna ask you to do it yourself because this one's kind of tricky. And let's just say what you come up with before I teach you. Austin probably forgot this one already. Now the problem is, no, I'm not gonna tell you what the problem is. I want you to find out yourself. I think Anthony remember how does it work. Daniel remember how to work. I don't know if Austin remember how to work.
That is a problem. You can't do like chain rule. You're not.
There's only u substitution. So far your tool for antiderivative only power rule and u substitution. That's it. There's no chain rule. There's no quotient rule. There's no nothing. Remember, your idea is convert everything to u and du. Hopefully you figure out. Obviously, you gotta write u, right? U equal to what?
2x plus 1.
2x minus 1.
Oh, yeah.
Charlie, what are you playing?
Oh, I'm doing like 29 computer labs basically for my first period. That's
Are you talking about?
yeah,
AI?
dude, sucks.
No. We should make it
Oh,
like
I have a,
weird.
something wondering if you want to help me with. I want to help out create augmented reality for inside a classroom. Do you know how to do that?
Yeah, isn't that
Augmented reality, like you can only see through your phone, and I want to do with the desk and washer and the cross section. Huh?
Pokemon Go?
I was 30.
Yeah. Yeah, I know.
I have no idea.
Yeah, but you can figure out YouTube.
42 labs.
What are you gonna pay? What are you gonna pay Shelly?
I don't know.
$1 an hour? Chinese? So much job.
Chinese.
Wait, add me to your YouTube channel and I'll put down the WhatsApp on your computer.
Okay.
Do it now.
No, I'm busy right now. I'm teaching.
You're not doing anything.
I'm teaching him.
So yeah, my first grade teacher sent us like 29 labs due in 50 minutes on Tuesday, which difficult but can like be slightly doable.
I would've
Once, yes,
So I'm not gonna do it.
sure. Wednesday was like
Wait,
Well,
didn't he lock them?
what?
After the period?
No.
Oh, he locked them for us. So we can't, we have the period to do it. Wow. The box. Because we're gonna take them out.
Yeah, but like I still haven't seen.
Yeah, I know. I was 30 and I thought.
I'm pretty generous about grading.
Yesterday we had like 43 labs due in 50 minutes, which is not ever possible for anybody ever. 43 I did like 3 of them and then stopped. I don't care.
Okay.
But you wanna-
Jared, did you figure out?
Thanks, though.
Okay, he figured out. Okay. What did you do?
So do that and then solve for x, like so do like solve for x with the u.
Very impressive.
Okay.
2dx. See, I know you can do it. So square root u, and this one's gonna du over 2, right? But there was an x in the front. Now you can move the 1 over, and u equal to, wait, hold on a sec, x equal to u plus 1 over 2. Is that what you did? Okay. So therefore, it's gonna be u plus 1 over 2 times square root u times du over 2. So I can move all of them outside. And that's going to be u to the 3 over 2 plus u to the 1/2 du by 4. Because c is not going to change. So that's going to be 110, right? Minus 6 u to the 3 over 2. Let's see. And we can figure out.
I thought it was already 227.
So now.
You need to tell me when I leave.
Is that okay?
45?
Okay.
No.
Now, okay, but sometimes you got this. This one, what u has to be. You want to think about u is equal to something where it can help you solve the problem.
What's to the right of the sine of 3x?
Integration. Oh, cosine 3x, sorry. Right, left. I got confused right
I
now.
don't know.
What to the 3? Sine to the 3.
Yes, under the third power. U equal to what?
3x.
Think about if you go to 3x, what is du? Du is what? 3, right? 3dx. That doesn't help me because you still have cosine of 3x. So what did u equal to? You always want to think about what du is, and du should be have something can help you cancel out with the original function. So whatever it is should be present in original function.
3x negative 50.
No. U equal to what? Sine of 3x, actually. Think about why you go to this du equal to cosine of 3x times 3 times dx, right? So then you can say du equal to 3 cosine 3x equal to dx. So I can change that to u to the third cosine 3x and then du over 3 cosine of 3x. So this will cancel out. It becomes a normal integral. And that's u to the 4 over 4. Times 1/3, right?
Oh, I'm so dumb.
So it'll be sine to the 4 of 3x over 12 plus c.
So like these all work out nicely always. Like in the real life when stuff doesn't work nicely, you just computers solve everything or like or is there a way to solve every integral? Like that's kind of my question.
Or there are sometimes like even you plug in let's say Wolfram, it can even solve. Like if you type in like MIT integration B
Yeah.
into those Wolfram computer software, they don't
They won't
able
be-
to solve. You have to outmaneuver the questions.
Yeah.
Like if you look up MIT's integration competitions, shit, those kids are like phenomenal.
So then they're doing like insane stuff. Like even if it doesn't work out.
They'll figure out a new way to do it. And a lot of time they don't figure out. Pretty much 10 questions they assign, only 2 questions were solved by the students.
So is there a way to do every single like integral kind of?
Well, probably not because
They're not, but
but I will say I hear the really cool thing is the people who come up with the questions are pretty awesome.
yeah, like they someone has to come up with
Yeah, someone had to come up with questions.
like
Has to be able to integratable.
if this was like cosine 2x or something. Like could they figure out how to go from there? Do you know what I mean? Like even if you change that one thing, they can't cancel.
Oh yeah, a lot of like if you want to look at it, just look up integration B competitions.
Yeah.
There are kids that just sit there and struggle and then sweating like just like and like pulling his hairs, and there's 2 people competing, one on each side of the board.
That's super intense.
And the projector poses a question, and the professor just says you got 3 minutes, and they'll try different way to do it. They'll try 10 different way to do it.
Wow.
And sometimes solution posted will be like there's 2 ways to solve this problem. Yeah, they are insanely good. The people who can do those integration competitions, they are amazing. They're like probably all of Buchholz kids, probably.
They'll go on to do that.
Yeah, more likely it's all Buchholz kids. Okay, is that okay? Okay, so now let's talk about definite integral. Definite integral, you have to do one more thing. So this is the part that you need to create discipline for you. Obviously, we know what u equal to. U equal to x squared plus 1, right?
Oh, because it's
And the du
yeah.
equal to 2x dx, and then du over 2x dx. And then if you do, the problem is you're gonna have here x and then u to the third, dx is du over 2x. This will cancel out. That's equal to 1/2 u to the 3 du. Now, the whole idea is you do not want to convert back to x. That including this value. So I usually draw 2 lines here and just change the boundary. So it'll be 1 squared plus 1 equal to 2. And then 0 squared plus 1 equal to 1. So it'll be just do it in term 1 to 2. And this is very important for BC because most of the time AB, a lot of you guys convert back to X and do it in terms of X. In BC, you got fundamentally different. We have to do something called trig integrals, and no longer will help you to do that. So you always have to do it in terms of a new things, which is u substitution. So I'm just gonna not going back to X at all. I don't change the u back to X. I just change the boundary. I'm just doing it in terms of u. A work is a lot more efficient, so it'll be 4/4 times 1/2, and between 2 to 1. So it'll be 1/8, 16 minus 1/4. And then that's equal to that's equal to what? Can't do math. This is 2 minus
If you take out the 1/4 from that,
what?
Would you get the -1/4?
yeah, because you took out the 1/4. So
Oh, okay, so that's my fault. This one is 1. So it'll be what? 15/8?
Which
Is that okay? Okay.
where'd you get the -1 from?
You had to plug in the higher bound, subtract the lower bound. Okay, so the next one is you're gonna do it on your own. And I'm gonna give you the harder questions. This is the harder question. And hopefully you can do it on your own. Oh, Charlie, you're on time.
Yeah, I tried to come at the beginning, and then Mr. Shiraz was camping outside the
Who?
hallway.
It's like
The assistant principal. He
like
was
Which
really
one?
standing right outside your door. I was like, I have to go get my laptop. And he's like, nope.
Assistant principal, which one? Sheffer? Sheffer? With the like kind of freckles, pimples.
Does he look like Mr. Bro?
Yes, that guy.
Does he go to what?
Yeah, it's Sheffield.
Sheffer?
The one with like he was at the tool, he was at the
Yes.
Close to the thing. Charlie, close to that thing.
Wait, did you tell me so you were coming in days? No, I said I'm gonna get my laptop in 6 weeks. I forgot.
It opened again.
like
No, they have a key to open it. It just say we just say we're in the calculus grind.
Are they really gonna get mad at you?
No, they have done that before. That's why they hide behind the door.
they've never done it because every pep rally last year we stayed here.
Yeah. The best one. May take off? Not a play take off? That's cool. Maybe perhaps. It's a game. Ready? I haven't played since last year.
Jared, I need you to finish this problem. This one's harder though. This one you had to use the back substitution.
Is it homework?
Yeah. But this is one question that you guys have to be able to do.
Is it posted?
Not yet. Make sure you change your boundary and do it in terms of u. I recorded just in case. Did I press record? I did. Seriously?
Yeah.
Me need to be productive, like other pen. Now I have new ops in school. I thrive. with more ops. Use substitution.
Is it like that entire worksheet?
Huh?
Is it that like long worksheet?
I think so. Let me check. I don't know if it has a use substitution here though.
Would this be? Wait, it's not. It's not the pictures.
Think of
Or would it be? Or new? Yeah. Oh yeah, we can do all of that.
The problem is there's a natural log.
that's actually fair. It was most
There's a natural log integration.
Yeah. Then you do this. With the integration, did we learn the neural natural log?
whenever you
Yeah.
maybe
I mean, Charlie haven't.
natural language. Oh, you're right. You were so right.
I think we learned.
Yeah, you should have one.
There should be a lot of. Oh yeah, I didn't get that. Shoot. Right.
Because the derivative of natural log is natural log.
There you go. Like at the bottom and make it negative intake integral.
I don't know what you meant.
Like I have like 1/4 and then like the integral from 1 to 9 u plus 1 over root u. Sorry, that's just completely top.
Matthew, can you look at his work? Because I don't understand what you're saying.
We get against so shoot. U equals 2 x 1.
Okay, you.
Oh, I didn't actually. Probably be easier.
It's when you say top.
So split.
Okay.
You could one have. Look, I got here. Because that nice fish. So you.
I got it. I don't know if it's right now.
What'd you get?
16 over 3.
Nice.
So to get the like the boundaries for the U, you set the X boundaries. or
I
you
change
set-
it to the U boundary. I just do it in terms of U. Because I don't want to convert back. I'm gonna stick with U. Now for AB kids, they always get confused. Do I do a U and the X because they try to do both? But I always tell students just change everything to U because that's how AP exam write a question. Especially they can write a multiple choice question that you have to convert the boundaries.
'cause you can convert back to X. right?
You can, it still will work, but it's not a best way. Especially go to BC because we have to say like tangent of data is equal to X over 3, and we're gonna change that data to the X in term of data, and then that becomes a lot harder if you don't get used to it now. That trig substitution part is gonna be it's impossible. It's not like impossible to do, it's just much more tedious.
Whatever.
U plus 1 over 2 equal to U plus 1 over 2 equal to X. So it'll be U plus 1. Don't open a door like that. Don't open a door like that.
Yeah, that's crazy. Yeah.
We got homecoming. It's exciting, bro.
Wait, do I do streaming first?
When you were a freshman, was that hard? Was it bro?
I didn't.
Now
Yeah, that was cool. I put the homework on but I didn't go intensive for that.
It's been zero for like last year.
But now it's hard. Mr. G, can you give a challenge one?
Huh?
Like
Come
what-
afternoon.
Huh?
Come afternoon. You were not here last week.
Yeah, tutoring. Tutoring.
No, the math come.
Yeah, that's what I'm saying. I told you.
Yeah. Last week they were doing some like what was that question that we do, Matthew? That Luke got that one integral question with the natural log and sine of x, and do you still have that question?
Wait, do you have the one?
Do you know how he did it though?
Yeah, you just like did.
Yeah, it's
Whoa.
some hard stuff, right?
Yes.
Were you able to do it?
I looked at it and I didn't. Like I had no idea what to do. 'Cause I didn't. No, you could do.
Yeah. Luke was like on top of it. Luke Davis.
Oh, shoot.
Yeah, I don't remember what year, but I was. Do you still have the paper though? You can show Daniel. Daniel say want a challenge problem.
Yeah, we try.
Did you get 1/4 times 2 over U?
Do you have it?
It's 16 over 3.
Yeah.
What did you get for your
Hey, bro, that one is good. 1.5 dash. 2 starts U.
Why they?
3.
What are they doing?
2 hours. Plus 2.
Wow.
Did you do your boundaries wrong? Or did you do it actually something? You got it. So 9 and
No, I don't have it. I think so. Thought I did.
and then 1/4
You have that motion like that.
plus 2/3.
Motion.
You know,
25.
14 minus
Wait, are you going to?
8 over 3. Is that right?
What's that working?
Why? Oh my god.
No way.
You have 0?
I've got, well, I
14 out of 24.
if I ask Mr. J.
You post the homework yesterday?
Huh?
Post the homework?
Yeah.
You spoke to one of them?
I said it, and I said the elevator is not low too.
Did I do some math wrong? Oh, this is -2.
Normal.
Did you ever play air hockey? Yeah.
I'll tell you what. What? I'm related to the damage.
How did you, bro?
Well, really? Make the table.
Reading, well, I'm actually illiterate.
What's your school, man?
Progressively got worse.
Is it above 600? Above 600? Yeah. Oh. What was the one?
Oh, like my reading progressively got worse. Actually, no.
What was your best? What was your best?
Are you saying mother to me, or you just? Oh.
Alright.
Well, I was just like never like read it in time. And, like,
I got you, yeah. And you weighed 50.
I got 16 over 3. Go. Charlie, you got 16 over 3.